So our next lesson is on absolute value equations and inequalities. Now don't write this down. I just want to kind of briefly go over what absolute value is. So when we talk about a number line, okay, we'll say zeros in the middle. 1, 2, -1, -2. Okay, so we have a number line. Now, absolute value by definition is the distance from 0. For example, if I had the absolute value of 2, and I'm talking about this number here, well, how far away is that from 0? So I'd count 1, 2. So that would be 2. Now, is there another number that is also 2 away from 0? And the reason we use a number line here is because number lines go in both the positive and the negative direction. Because while 2 is away from 0, -2 is also 2 away. So absolute value of -2 is also 2. So we're going to have two separate answers when we do absolute value equations and eventually absolute value inequalities. So this is our first example. We have the absolute value of x is equal to 7. Now I know that whatever number I put in here, right, when I take the absolute value of it, I should get 7. And we're going to start with a very basic absolute value equation so you get used to how we have to handle this situation. Now, once these absolute values signs are by themselves, like there's not a 3 out here, we're not adding anything to it, I want to break this down because what I know is that inside of the absolute value symbol, which is currently an x, could be 7, but it could also be -7 because both -7 and +7 are 7 away from 0 on the number line. Okay. Now, to do a more complicated example, like example 2 here, what if we had x, actually let me change that, what if we had 2x plus 3 is equal to 11. So example 2, absolute value of 2x plus 3 is equal to 11. Now I know whatever's in here, right, could equal 11 or could equal -11. So I have to figure out, well, when does 2x plus 3 equal 11? And when does 2x plus 3 equal -11? So I have to break this apart into two different equations because both 11 and -11 will work. Both of those are 11 away from 0. And now I solve. Here I'm going to subtract 3 from both sides. Those cancel. I'm left with 2x equals 8. And I divide by 2 on both sides. X equals 4. Now on this side, subtract 3 from both sides. Those cancel. I'm left with 2x equals -14. Divide by 2. And x could be -7. So let's check these ones out. If x is 4, 2 times 4 gives me 8, plus 3 would give me 11. So that one works out. Now if x is -7, 2 times -7 is -14, plus 3 is -11. And the absolute value of -11 is 11. So that's why we have to split this up into two different equations. Now say for instance I have this equation. 3 times the absolute value of x plus 2 minus 8 equals 13. Now you want to be careful here. When we have a number outside of the absolute value symbol, we don't distribute in. Okay? First we have to get the absolute value symbol by itself, and then we can talk about trying to solve for x. Now, what's with the absolute value symbol is subtracting 8, right, and multiplying by 3. So to solve this one, my first step is going to be to add 8 to both sides. Those cancel, and I'm left with 3 times the absolute value of x plus 2 equals 21. Then I can divide by 3 on both sides, and I'm left with the absolute value of x plus 2 is equal to 7. And then I can separate it to either x plus 2 equals 7 or x plus 2 equals negative 7. And I subtract 2 from both sides, so x could be 5. Subtract 2 from both sides, or x could be negative 9. So my two answers here would be negative 9 and 5. So two separate answers for that one. Oops, sorry, I went off the page a little bit. Negative 9 and 5. Now we're going to move on to absolute value inequalities. All right, now I don't want you to write this down either, because we're just going to talk about absolute value inequalities. So let's say that we want the absolute value, right, of some number, let's say x, and let's say we want that to be greater than 7. Well, what are the numbers? If we look at the number line here, 0, 1, 2, 3, 4, 5, 6, 7, 8. And you can pause if you want to write this number line yourself. Okay. So the absolute value of some number is greater than 7. So remember, when we talk about inequalities, we have a range of solutions. We're talking about now trying to find the values where the distance from 0, because that's the definition of absolute value, is greater than 7. So 5, for instance, would not work, right? Because 5 is 5 away from 0. So the numbers that are greater than 7 away from 0 would be, well, not including 7, but all of these values here, right? All of these values are greater than 7 away from 0. And what that looks like is, well, x is greater than 7. Now, conversely, when we talk about things in absolute value, we also have to think about the negatives. So negatives also can be away from 0. So negative 7. And it's all these values are also more than 7 away. And that inequality graph looks like x is less than negative 7. So when I have an equation like this, okay, or sorry, and when I have an inequality like this and I'm trying to solve it, what I'm doing, similar to equations, is I'm breaking it down into either x could be greater than 7, so what's inside, right? Almost like taking away the absolute value symbols and rewriting what I have left. Or, because looking back at compound inequalities, this would be an or, right? Or x can be less than negative 7. Now, just like before, if this gets more complicated, this gets more complicated when we try and solve it. But absolute value inequalities just break down to a compound inequality. The only difference is, are we talking about distance that is greater than some number or less than some number? Okay, let's take a look at what happens when it's less than some number. All right, let's take a look at this one. So let's say, for example, now I have the absolute value of x is less than 4. So again, I'm talking about the distance from 0, but I have a range of solutions. So what are those values where the distance is less than 4? Well, 3 is less than 4 away, so 3 would work. 2 would work, 1 would work, 1.5 would work, 2.5, right? It's all these values going to 0, just not including 4. So this one here, x is less than 4. Now, conversely, right, we can also have a negative version. So -2 is only 2 away from 0, so that would work. -1, 0.5, right? -3.5. All of these values, not including 0, not including -4, are also going to work. So that one looks like x is greater than -4. So if I were to break down this inequality here, I would leave 1 by itself, right? So just x is less than 4. But to handle the negative version, I have to say, well, x also has to be greater than -4. So I flip the inequality symbol and make it a negative. Okay? Now this one's an and if you look back at and inequalities, it's more of a restriction, right? It has to be inside between -4 and 4 here. Okay? Because if I start going all the way down here, if I say x is also could be like less than 4, is all of these values, right? -5 is less than 4, -17 is less than 4, but that's not less than 4 units away from 0. Okay? So when I break down inequalities with absolute value and equations, I'm always breaking it down into 2 different inequalities or equations, but getting rid of the absolute value symbols. So this is what we just talked about, but it's written in a more formal way. This you actually are going to put into your interactive notebook. So it's the key concept. When we have an absolute value inequality that has a less than or a less than or equal to symbol, we're going to treat it as an and inequality. Right? If we have a greater than, okay, like the absolute value of A is greater than B, that's going to be treated as an or inequality. Okay, so greater than means a greater distance away, so it can be much more numbers, right? An infinite amount almost. If it's and, right, if it's less than, then it can only be a certain amount away from 0. Okay, so those are some small examples about kind of examples that we already did. So go ahead and pause the video and write down the key idea, and then we're going to do 2 more examples involving absolute value inequalities and how to solve those. So our 4th example is the absolute value of 8n is greater than or equal to 24. And again, I'm talking about greater than or equal to. So the distance is greater than 24, or whatever that number n turns out to be. So if I have greater than, I'm looking for numbers that are going away from 0. So I'm going to be splitting this up into an or inequality. So I've got now 8n is greater than or equal to 24, or 8n is lesser than or equal to -24. So remember here that the key is I switch that inequality symbol, or flip it, and then this becomes negative. And I do that for every single one. Doesn't matter if it's in greater than or less than. And then I solve each one individually. So both of these I divide by 8. I get n is greater than or equal to 3 over here, or n is less than or equal to negative 3. And then I graph those separately. So there on a number line you can see negative 3 and 3, with 0 right in the middle. All of those numbers, right, that are greater than or equal to 3, less than or equal to negative 3, have a distance that's greater than, okay, greater than 24 away when you multiply it by 8. So that's example 4. And now we have example 5, which is our last example. The absolute value of 2w minus 1 is less than or equal to 9. So we're looking for the distance is less than. That means we should have an and inequality, right? Because it's going to be between two numbers, right, including 0. So we break this apart. Again, 1 just stays the same. 2w minus 1 is less than or equal to 9. It's an and inequality, and we switch this, right, inequality symbol, and then we make that one negative. Now, kind of the nice one about, or the nice thing about these types of absolute value inequalities is that the steps that you use to solve them are the same. On both of these, and you saw this on the previous example, on both of these, my first step is to add 1 to both sides. Now, I'm not going to get the same answer when I add 1 to both sides, but that is my first step. Because now I have 2w is less than or equal to 10, and 2w is greater than or equal to negative 8. And then again, I'm going to divide by 2. When I do that, I get w is less than or equal to 5, and w is greater than or equal to negative 4. And then all I have to do is show that on a number line. So between negative 4 and 5, with 0 just about in the middle, okay, all of these values will work. Okay. And that's it for absolute value inequalities and equations. So you're going to do some practice problems on the left side of your textbook and show your teacher, and then you move on to the textbook practice. And on the left side, you're going to solve these 4 problems. It says solve and graph. You don't have to graph number 1 and number 2, but 3 and 4 you will have to graph.